Hi everyone, welcome back to the channel. So, if you've been following this channel, you probably remember our videos on what is field in physics and the magnetic field, the force that powers our modern technology. If you haven't seen them yet, please go and check them out on the playlist because today's topic builds directly on those ideas. Because today, we're diving deep into one of the most powerful and mysterious concepts in all of physics, the electric field. It is the invisible force that powers lightning, runs our technology, and even all the atoms in your body. Let's uncover how scientists throughout history discovered and shaped this invisible force. Our story begins over 2,000 years ago in ancient Greece. Philosopher Thales of Miletus noticed that when he rubbed amber with fur, it attracted a small piece of straw. He didn't know it yet, but he just discovered what we now call the static electricity. So, centuries later, English scientist William Gilbert, physician to Queen Elizabeth I, gave this mysterious effect a name called the electrox, meaning like amber. Gilbert also proposed something radical for his time, that the earth itself acts like a giant magnet. It was the first step toward understanding the invisible force that reached across empty space. In 1785, French physicist Charles-Augustin de Coulomb set out to measure this mysterious force precisely, using a delicate torsion balance. He found out that electric force between two charges follow a beautiful mathematical rule. So, it means that the closer two charges are, the stronger the force, and as they move apart, the force weakens with the square of the distance. Coulomb proved that electricity obeys predictable laws just like gravity, but he didn't explain how the force acts through space. That puzzle would inspire the next generation. Enter Michael Faraday, one of the most greatest experimental physicists in history. Faraday imagined that charges don't just pull or push each other magically. Instead, they create something in the space around them. He called it a field of force. Faraday used iron fillings and magnets to visualize this invisible world, revealing elegant curved patterns that represent the line of force. He proposed that every charge set up a structure in space, which is the electric field, and any other charge placed within that region feels a force. This simple equation defined the electric field as the force per unit charge. But Faraday's ideas were mostly qualitative. He could describe the field, but not calculate them. That is where James Clerk Maxwell came in. In the 1860s, he turned Faraday's visual line into mathematical equations, now known as Maxwell equation. So, this equation means that every electric field originates from electric charges. And this equation means that a changing magnetic field can produce an electric field, the principle behind electric generators and transformers. When Maxwell combined all these equations, he found something revolutionary. He says light itself is an electromagnetic wave, a ripple of electric and magnetic field moving through space at the speed of light. For every single charge, the field radiates outward in all directions. So, that 1 and radius square relationship comes from geometry. The field spreads across the surface of the sphere, whose area grows as 4 pi radius square. Between the opposite charge, we get a beautiful dipole field, and between two parallel plates, the field becomes uniform, which is actually described by this small equation. These simple equations power technology like the capacitors, the CTRS, and the touchscreens. They literally rely on the energy stored in electric fields. Every electric field is connected to a potential energy. As you move through a field, the potential changes, like height and gravitational field. So, that relationship is described by this equation. The negative sign shows that the electric field points in all directions where potential decreases. And when the potential difference between two regions becomes large enough, like in storm clouds, the electric field tears electrons from the air, creating lightning. It is nature's most dramatic display of electric energy. Today, we know the story doesn't end there. In quantum field theory, every particle like electron, proton, photons is a vibration in a field. The electric field isn't just an invisible influence anymore. It is part of the fundamental fabric of reality itself. What Faraday imagined as smooth, continuous line we now describe as quantized energy packets, which is photons. Even in a vacuum, tiny electric field fluctuations constantly appear and vanish, the quantum form of space. From the atom in your body to the circuit in your phone, electric fields are everywhere. They bind electrons to nuclei, they power our cities, move electrons to microchips, and ignite the engine of a rocket. So, every screen, every sensors, every wireless signals are all controlled by electric field, quietly shaping modern civilization. From Thales amber to Coulomb's law to Faraday's line to Maxwell's equations, the electric field is one of the most greatest ideas in all science. It is the invisible architecture of the universe, the bridge between matter, energy, and light. So, if you do enjoy this deep dive, go and watch my earlier videos on what is field in physics, the invisible code of reality, and the magnetic field, the force that powers our modern technology. They will help you connect every piece of this puzzle. And don't forget to like, share, and subscribe, because next time we'll be exploring some fields.